When we take measurements in our world around us, there are two very distinct families of measurements. One is what we call a scalar, and it's the simplest. It's just measuring how big something is. The second one, and the one that this unit you're about to study now concentrates on, are what we call vectors. Vectors have two attributes, always two. One is how big it is, the magnitude, and the second attribute that vectors have are direction. There's always magnitude and direction associated with every vector. So a vector has magnitude and direction. A scalar has magnitude only. If we were to look at scalars, since they're a little bit simpler, we'll look at them first. Some examples are temperature. And we measure temperature with a thermometer maybe, and we've got Celsius, Fahrenheit, Kelvin, and it's just a single entity, a single characteristic. Density, mass over volume, and we can measure that. Just distance. Distance is how far something has travelled, how long it is between 2 points, and distance we can measure in centimetres, metres, kilometres. Speed, how fast something is travelling. So there are many more, but there are the four examples of a scalar. Let's go back to vectors now. We've got magnitude and direction. Force will have magnitude and the direction in which the force is acting. Magnetic field, displacement, and velocity. Once again, there are many more, but these four are an example of what a vector is. It's not by coincidence that I've got these two here sitting on the same line. We've got displacement and distance. So let's just have a look at an example and see what is the difference between displacement and distance. We'll just get another colour and we'll draw up our north, south, east, west. So north, normally up the page, south, east, west. And so we have an object that simply moves from the origin. We'll call this the origin here, where they intersect these lines. And say it moves 3 units out in the easterly direction, and then it travels 2 units up in the northerly direction, and a unit back in the west direction, another unit up in the north, and then 2 units in the west direction to finish up. The distance travelled would simply be these 3 units plus the 2 units up here, 1 unit, 1 unit, and 2 units. 3 and 2 is 5, 2 is 7, 2 is 9 units. Okay, so that's a scalar quantity. The displacement is the net result of where this object is finished in relation to where it started from. So if it started here, it has really only moved 3 units away from where it originally started from. So 1, 2, 3. So it's 3 units. And we set up here that vectors must have magnitude and direction. And so we're talking about displacement. So we've got to give, as well as a magnitude, we've also got to give a direction, and it will be 3 units north. So therein lies the difference between distance and displacement. We can talk a little bit later about the difference between speed and velocity as well. Okay, so just summing up then, vectors, magnitude and direction, 2 entities, a scalar, magnitude only.